There are rare moments in astronomy when a single object simply refuses to follow the rules the universe has set for it. Moments when the numbers buckle under their own contradictions, when every computer simulation falls short, and when the scientific community quietly starts to worry that the thing they're observing isn't just an anomaly, it is fundamentally wrong. That is exactly what is happening right now with 3I Atlas. In recent weeks, this interstellar traveler has started generating signals so conflicting, so physically inconsistent, and so violently at odds with standard comet behavior that researchers have been backed into a corner. Either the comet is shattering into dozens of pieces, or our grasp of what we are witnessing is flawed to a degree that makes even the experts uneasy. But then the latest images came in, and the situation turned even stranger. Because the one theory that held water, that 3I Atlas must be fragmenting, has now been disproven. It isn't splitting apart. It isn't scattering debris. It isn't crumbling under its own mass loss. It remains perfectly intact, solid, singular. And that discovery has unlocked a door no one was ready to open. Something is deeply wrong with 3 Atlas. And tonight, we're going to dissect this mystery piece by piece, layer by layer, until the sheer scale of what is occurring becomes impossible to overlook. To grasp just how bizarre 3 Atlas has become, we must begin with the event that triggered the first alarms. On November 9th, astronomers snapped photos revealing a massive tail, actually two massive tails stretching millions of kilometers through the void. One pointed away from the sun, as expected. The other pointed almost directly toward the sun, creating an ultra-rare feature known as an anti-tail. But the real issue wasn't the direction, it was the scale. For a comet to generate tails that long, gas needs to scream off the surface at blistering speeds. Yet 3I Atlas releases gas at roughly 1,500 kilometers per hour, sluggish by cosmic standards. At that velocity, creating tails millions of kilometers long demands weeks or even months of continuous outgassing. Yet images taken mere days earlier showed absolutely nothing. No faint tail, no jets, not even a haze of dust. The comet went from total silence to explosive activity in a time frame that physics suggests shouldn't be possible. It was like watching a match explode into a bonfire in the middle of a rainstorm, without ever seeing the spark. And when scientists ran the numbers, the explanation became even more alarming. To sustain tails that enormous, 3I Atlas would need 1,600 square kilometers of sunlit surface area. Essentially, a spherical comet 23 kilometers across. But Hubble measured the nucleus at only 5.6 kilometers across, 4 times too small, which means the tails we were seeing required a comet vastly larger than the one we actually have. And that contradiction snapped the model in half. Once astronomers tallied how much material those tails held, the scenario went from strange to physically impossible. Based on brightness and tail size, researchers estimated that 3 Atlas was ejecting material at a staggering rate of 50 billion tons a month. But the comet itself is only estimated to weigh 33 billion tons in total. Put simply, the comet was losing more than its entire mass every single month. That shouldn't just be improbable, it should be fatal. No object can shed more mass than it possesses unless it is breaking into multiple chunks, revealing fresh surfaces and shedding material like a collapsing iceberg. We have seen this exact phenomenon before. In 1992, comet Shoemaker-Levy 9 broke into 21 fragments. The mass it released seemed impossible until we realized it had shattered. Fragmentation explains the extreme mass loss. It explains the sudden brightening. It explains the multidirectional jets. Everything suggested 3I Atlas was suffering the same fate. It was supposed to be falling apart. The math demanded it. The physics required it. The behavior insisted on it. But then the truth arrived in new images, and all our assumptions fell apart. As the data stacked up against 3I Atlas, astronomers were certain of one thing. This comet had to be fragmenting. It had to be. No intact object could survive losing more material than its entire mass. No single object could produce 7 jets in one day and massive tails the next. And certainly, no intact object could endure its October 29th perihelion, its closest brush with the sun, without cracking under the thermal stress. Comets routinely break apart near the sun. Many simply don't survive the encounter. 3I Atlas faced temperatures that should have torn it open. The jets exploding from its surface should have acted like thrusters, ripping the nucleus into chunks. Every simulation confirmed it. 3 Atlas could not be whole after what it had endured. Scientists prepared to study the fragments, to analyze the debris field, to measure the breakup. Fragmentation was not just a theory, it was an inevitability. Or so it seemed. On November 11th, astronomers David Jewett and Jane Liu captured the clearest view yet of 3I Atlas using a telescope in the Canary Islands. What they found instantly rewrote the script. Their report had a disarmingly simple title: 3 Atlas still single, a nucleus intact, a coma glowing. A region 500,000 kilometers wide around the object was carefully scanned, showing zero evidence of fragmentation. Every method designed to reveal even the smallest shard of debris found nothing. Not one fragment, not one trail of dust separating from the nucleus, not a single sign that the comet had split. Despite the math insisting it must be cracking, despite the tails demanding it should be breaking up, despite the jets screaming that fragmentation was the only answer, 3I Atlas remained whole. This was the moment astronomers realized something was profoundly wrong, because the comet's behavior and its condition simply didn't match. Its activity was catastrophic, yet its structure was pristine. It was like watching a volcano erupt violently without damaging the mountain itself. A paradox, a contradiction, a warning. The new images confirmed something else. 3I Atlas was producing not one, but 2 massive tails. The normal tail was expected, but the anti-tail, that was something astronomers rarely see, and almost never with this level of precision. It pointed at the sun with an offset of just 9 degrees, a nearly perfect alignment. Anti-tails can happen under rare geometric conditions, but here the geometry didn't add up. Since 3I Atlas wasn't fragmenting, the dust wasn't coming from multiple pieces spreading out. The tail appeared to be forming from a single nucleus, maintaining a stable direction despite the comet's rotation. And what made this even stranger is that anti-tails don't just appear overnight. Yet this one did. It arrived at full strength after days of total inactivity, contradicting every model describing how dust distribution should work. It was yet another sign that while the comet's activity was extreme and chaotic, the object itself seemed impossibly stable. Once again, the data disagreed with reality, and the contradiction deepened. 3 Atlas passed its closest point to the sun on October 29th, a moment when most comets experience violent stress. This is when sublimation becomes intense, when gases burst outward, when the nucleus heats unevenly and fractures under pressure. Many comets simply don't make it through perihelion intact. Yet 2 weeks later, 3I Atlas wasn't weakened. It was supercharged. It produced jets, tails, and massive outgassing, all while remaining perfectly whole. The thermal stress that should have shattered it didn't even crack the surface. The explosive loss of tens of billions of tons of material didn't erode it. The violent expulsion from its core didn't distort the nucleus. It behaved like an object immune to the very processes that define comets. This forced scientists to entertain a disturbing concept. Maybe 3I Atlas isn't acting like a comet because it isn't built like one. Something about its structure must be fundamentally different. Something ancient, something hardened, something the solar system has never witnessed. The next theory to gain traction was one rooted in 3I Atlas's origin. This object likely predates the solar system by billions of years, possibly being 7 to 10 billion years old. During that vast stretch of time, it would have drifted through cosmic radiation fields, absorbing high-energy particles that slowly altered its chemistry. Cosmic rays might have hardened its outer shell, forming a crust unlike anything in our comet catalog. There is evidence for this. The James Webb Space Telescope detected 8 times more carbon dioxide than normal, suggesting cosmic rays may have converted carbon monoxide into CO2 over billions of years. That same radiation could have turned its surface into a dense, rigid shell, while the interior remained filled with ancient volatile ice. If the crust is sealed, except for hidden vents or deep channels, sublimation might occur in violent bursts, producing jets far more powerful than expected from its size. This would create massive tails and extreme activity without necessarily fragmenting the nucleus. In other words, 3I Atlas may be behaving this way because it possesses a structure the solar system has never encountered. But even this theory only tells half the story. The contradictions kept piling up. If 3I Atlas isn't fragmenting, and if the exotic crust theory only explains some of its behavior, then astronomers are left with one final, unsettling possibility. Perhaps our calculations are flawed. Maybe the tails aren't as massive as they seem. Maybe the brightness exaggerates how much material is actually leaving the comet. Maybe the comet is losing only 5 billion tons per month instead of 50 billion. That would still be extreme, but survivable. The problem is that this method of calculating mass loss has worked for decades. It worked for every comet we've ever studied. If the method fails here, then the problem isn't the method, it's the comet. Something about 3 Atlas, its chemistry, its crust, its internal pressure, its age, or something we haven't even identified, is pushing it outside the boundaries of known comet behavior. And when an object violates every rule of physics and still remains whole, active, and accelerating, the universe is telling us that we are missing something fundamental, something big, something hidden behind the strange glow of this impossible visitor. Something seriously wrong. And this is only the beginning. When we step back and look at everything 3I Atlas has done, everything we've measured, everything we've calculated, everything we've witnessed, it becomes impossible to pretend this is just another interstellar comet drifting silently through the solar system. Nothing about this object behaves the way it should. Not its brightness, not its mass loss, not its tails, not its jets, not its survival, not its structure, and certainly not its refusal to break apart despite every law of physics screaming that it should have shattered weeks ago. What we are observing isn't just the story of a comet. It is the story of a contradiction. An object physically tearing through every model we use to understand the cold visitors crossing our cosmic borders. Because here is the truth most astronomers won't say aloud. 3I Atlas is a paradox, a contradiction wrapped in dust and ice, a mathematical glitch drifting through space. It is losing more material than it contains, yet remains whole. It produces tails so massive that they require 4 times its measured surface area, yet the nucleus is smaller than any comet capable of generating them. It fires jets in 7 directions like a dying star, yet the nucleus shows no cracks, no fractures, no fragments. It passes through the most violent part of its orbit without losing structural integrity. It behaves like something fragile and explosive while appearing like something rigid and ancient. It is almost as if the object is obeying one set of rules on the outside and a completely different set of rules on the inside. And that is the part no one wants to touch. Because if 3I Atlas is natural, then we are witnessing a new category of interstellar object. One shaped over billions of years, hardened by cosmic rays, sculpted into a form no comet from our solar system has ever taken. But if 3I Atlas is not natural, if the violent jets, the impossible mass loss, the sudden appearance of enormous tails, the perfect structural survival, the rare anti-tail alignment, and the flawless integrity of its nucleus are symptoms not of chaos but of design, then this object is not just old. It is engineered. Engineered by time, by age, by conditions we have never seen, or by processes we have never imagined. Either way, the conclusion is the same. Something is seriously wrong with 3I Atlas because something about it does not belong here. Maybe it's showing us a kind of interstellar chemistry our models cannot yet describe. Maybe it's revealing what comets look like in civilizations older than our sun. Or maybe, just maybe, we're looking at something built to survive what no natural object ever could. What matters now is this. 3 Atlas has forced us to confront the limits of our understanding. It has shown us behavior no comet should have. It has endured conditions no comet should survive. And it has left behind a trail of physical impossibilities so large that the only honest reaction is to admit that something about this visitor is beyond us. If this video forced you to question what we thought we knew about interstellar objects, don't leave quietly. Subscribe, because the next update could rewrite everything we think we know about the universe. Give this video a like so more people can see the truth hidden inside these impossible numbers. And comment below what you think is really happening with 3I Atlas. Is it just an ancient comet behaving in ways we've never seen? Or is it something entirely different? I'd love to hear what you think about this, so drop a comment below. If you enjoyed our conversation today, please share this video and subscribe to help the channel grow. Every bit of support counts.